Hi there, welcome to Solving with Exponents. We're going to take a look at how we can solve equations using exponents. But before we get there, I wanted to take a quick moment and review how to simplify with exponents, because first we do need to understand these key concepts. So this is using some rules that we've already seen, but I always kind of like to start fresh with a quick review. So here you'll see I have a -1 exponent. So I always like to type either the word flip to help me know to flip something. A lot of people like to say the word move, and some people like to say the word switch. It kind of just depends which phrase helps you remember. The other thing that I kind of like to do is simplify what I have inside first, and then I'll worry about everything that's being moved and switched around. So I'm going to do something that kind of looks like this. So I can see 12 divided by 6. Well, that's easy. It's the same thing as 2 over 1. And then I'm going to go through with the other ones as well. So I see a to the -2. Oh, a to the -4. So you can either subtract exponents or you can move things around. So here I always like to move the bigger number. So here's a to the 4th, and then I can add my exponents. So I've got 4 minus 2, so that's a squared. And then the last one I have is b to the 3rd, b to the -1. Okay, this is a negative exponent, so this is going to move this to the top. So it looks like I have a b to the 4th. And then I still have a -1, which basically says, okay, everything is going to switch places. So for my final answer, I'm going to have just the 1 on the top. You can kind of see where that came in handy. 2a squared b to the 4th for a final answer in red. Welcome back. So on example 2, we have a lot going on here. So I think the first thing that makes this one a little bit easy is you can see I did a couple of steps at once, but I'll walk you through it. So here I did 2 cubed. I did x to the 4th cubed. So there's where x squared came from. I cubed the y. So there's y to the -6. And I also cubed the z. So there's z to the 3rd. The other thing that I did was I see that there was a -2 on the bottom. So what I did is I switched and moved that piece, all of this, to the top. So that's where this piece is coming from. And there I made the 2 exponent positive. And then from here, you can continue to distribute. You can square everything. So here's -3 squared. So there's where 9 came from. Here's x to the 4th. Here's y squared. And here is z to the 4th. Then it's just a matter of combining and multiplying. So here I've got 8 times 9 is 72. 12 plus 4, x to the 16. -6 plus 2 is y to the -4. And then you have z3. Z4 is Z7. Just be sure for that final answer, any negative exponents, you switch and move them to the bottom. So 72, x to the 16th, z to the 7th is still on the top, but y to the 4th has switched and moved to the bottom for a final answer in orange. All right, example 3. This one, again, it kind of depends on what you would like to tackle first. Some people like to take care of the squared first, and then some people prefer to simplify everything in the parentheses first. It really just kind of depends what you see. For me, I saw the squared, and so I distributed the square first to everything, and everything got squared. So you can see 3 got squared, which is where the 9 came from. I've got m to the -10 because it's -5 times 2. And then you can see I also squared the n. So I've got n2 times 2 is the 4. You also had to square everything on the bottom. So here's 4 squared to get you to 16. Here's m to the -2. 0 times 2 is still 0. And then I just simply brought this over and I made sure the colors kind of matched. Again, here's where you can decide what works best for you. I happen to see that the 9 on top and the 9 on bottom canceled out because I've got 9 divided by 9 equals 1, so that's why those canceled. And then I went ahead and combined a couple more things together. So I went ahead and added everything across. So here's negative 10 plus 1. There's where my negative 9 came from. And I did the same thing with my n. So I've got n to the 4th times n to the 4th gives me n to the 8th. And then you can see that the 9 canceled out. And n to the 0 also becomes 1, so that also went away. Just be sure for the final answer to simplify everything up together to give you the final answer in orange. So on this one, you've got an n to the 8th, n to the 1. So there's where the 7 came from. 16 didn't move around at all. And then I moved and switched this one to the bottom. So that gave me m to the 9 minus 4. So there's where the m to the 5 on the bottom came from for the final answer. So we have an area for a rectangular computer chip is represented by 112 a cubed b squared square microns. If the width can be represented by 8ab, find an expression that could give me the length. Okay, so really I'm just looking for L, which is this one. So if I'm trying to find what the length is, hopefully I can see that's just the area divided by the width. So I'm just going to plug in. The area was 112. I've got a cubed b squared microns. And then I still have an 8, I have an a, and I have a b. And then it's going to be the same old exponent story. Try to simplify as much as you can. So we're going to divide 112 by 8. And we're going to go ahead, subtract the exponents. And then we've got b squared and a b. Hopefully when everything simplifies, you get a nice, really friendly answer. So you're going to have 14 right here. A squared, so there's 3 on top, 1 on bottom, and 1b left over for a final answer in purple. All right, the last few that we're going to take a look at is solving with exponents. And what I mean by that is something that kind of looks like this. We love these problems. We hug these problems. You see, I did a little bit of the Jetsons theme because it's almost like a new age solving. It's like a weird futuristic type of solving. But if it helps, you're just going to focus on your laws of exponents. So here, laws of exponents say if I'm multiplying these together, then my exponents are going to add. And I'm going to keep the other side 2 to the 5th. Now it's kind of easy to see, well, now that the bases match, really, if I want the numbers to be the same, I just need the exponents to match. So really, I just need to be sure that these top parts are equal to one another, and then the numbers will be the same. And this works out really well because I just have to subtract 7 on both sides. So hopefully as long as x becomes negative 2, then I'm going to have 2 equal numbers. So let's try that same idea because sometimes the numbers aren't going to match. So on this next one, we're going to focus on the bases. Okay, these bases do not match. So I'm going to try to rewrite the bases so they do match. So let me think, okay? 16 is actually the same thing as 4 squared. And you can see I still have the x plus 2. The exponent hasn't really changed. And then 64 is actually the same thing as 4 cubed. So here's 4 for the base, cubed for the exponent. So again, as long as the bases match, now I can focus on solving with my exponents. So I'm going to have 2, and I've got x plus 2 equal to 3. And I can solve just like normal. So on here, I always kind of like to distribute by 2, since dividing by 2 may not be the most friendliest thing. And then just be sure that you subtract the 4 to move it over to the other side. So I've got 2x equaling negative 1. Final answer, just be sure you split everything by 2. So as long as x is equal to negative 1/2, my numbers will be identical. They will be equal. This one's a little bit nicer because the bases almost match. Okay, looks like 2 is a pretty small base. 32 could definitely be rewritten. So I'm going to leave 2, and I'm going to combine these and say 5x, because the exponents are going to multiply, equals, okay, is there anything that could work here? 2 to the what would give me 32? Oh, well, that's just super friendly. 2 to the 5th. So now I just have 5x is equal to 5. Final answer, as long as x is equal to 1, we are good to go. But it's all about rewriting using exponents. So let's see how exponents can continue to help us. All right, hopefully you saw some rules of exponents here. So one of them, I see I have a base of 5. The other one is 1 over 25. So what I like to do on that one is, again, do a little bit of rewriting. So here you can see that I have 1 over 25. Well, that's the same thing as 1 over 5 squared. And here, if I need to switch this to the top, I just need to make it 5 to the negative 2, because negative exponents will switch. And then I can do some rewriting. And now I can drop those bases and make the exponents identical to one another. And then set both of them equal and do a little bit of rewriting. So here you can see that I went ahead and I subtracted x to move it over. And then I divided everything by negative 5 to give me 2 over 5, or 2/5. And we will leave them as fractions since those answers are more exact. Let's try another one. So this one, kind of similar. It looks like I've got a base of 2 on this one instead. That one can't really get much smaller. So now I need to focus on 1 over 8. So again, try to think of using some exponents to help you simplify that. Well, 1 over 8, that's the same thing as 1 over 2 cubed. And again, if I need to switch that to the top, I can use some negative exponents to help. So instead of having 1 over 8, I'm going to rewrite that as 2 to the negative 3, because those numbers are identical. And then I can drop those bases and I can set those exponents equal to one another. So I've got 4x plus 1 is equal to negative 18x. And then I do what I do best. I start to move things over. So I'm going to subtract 4x to the other side and divide by negative 22x and get negative 1 over 22 for my final solution. Again, please leave it as fractions. And it's okay if they're not friendly. That's kind of where the laws of exponents can be really, really helpful. All right, this last one looks like I changed it up a little bit. Not only did my bases not match, 1 over 16 and 1 over 32, I also was sneaky and threw in an inequality, but we are going to treat it just like an equal sign. First things first, try to make those bases match, okay? 16 and 1 over 32. Well, the good thing is 16 is the same thing as 2 to the 4th, and 32 is the same thing as 2 to the 5th. I do need to do a little bit of switching, just like I did before, so I'm going to have to switch and move that to the top using some negative exponents. And then, again, we do a little bit of substitution, a little bit of replacing. So we're going to replace the 16 and we're going to replace the 1 over 32 using our new numbers. And then your bases match. So now your exponents just need to match. And then you can see that I went ahead and I did some distributing. So I multiplied by 4 to get the 8x plus 4. And then I dropped everything else. I went ahead and subtracted both sides by 4. So there's where my negative 9 came from. And then I just divided every single thing by 8. And so as long as x is less than or equal to negative 9 over 8, I will have a true statement. Thanks for watching. Stay tuned. We'll do a couple more examples in class together.